We are now getting into Chapter 4, where we're going to be working with functions. Section 4.1 is working with graphing relationships. So when working with graphing relationships, there are two types of graphs that you'll see. You'll see continuous graphs, which are graphs that are connected with lines or curves. For instance, this first example has the curves and the lines going on with it. The next type of graph you would see would be discrete graphs, where it has only distinct points. So notice this graph is representing theme park attendance, the people, and the population of the people with the years. So become familiar with what continuous graphs look like and what discrete graphs look like. Here we have an example working with graphs. It says relating graphs to situations. So this example is a problem we're going to solve. It says the air temperature was constant for several hours at the beginning of the day, then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents the situation. So it says it was constant for several hours at the beginning of the day. Then it rose steadily for several hours and stayed the same temperature for most of the day. So we have three graphs here, 1, 2, and 3, and we have to determine which graph represents this situation the best. Now some key words to tune into. When it says it's constant, that means it's a horizontal, meaning, for instance, you have your horizontal here, horizontal there. Here we have horizontal. Rose steadily is slanting upwards, so graphs A and B are showing slanting upwards, rose steadily. Stayed the same is representing a horizontal line. Graph B is showing the staying the same, or the horizontal line. Dropped sharply is going to be slanting downward, and graph B shows that. So, looking at these three graphs, which one is going to show the best of staying constant at the beginning, then rose steadily for several hours, and then it stayed the same temperature for most of the day? Notice graph B started constant, rose steadily, then stayed the same temperature for most of the day, and then it dropped sharply at sundown. I'm thinking graph B. Let's see what the answer is. Answer is going to be graph B represents the situation here, for example number 1. Here's another example. They want us to sketch a graph for the situation and tell whether the graph is discrete or continuous. Simon is selling candles to raise money for the school dance. For each candle he sells, the school gets $2.50. He has 10 candles that he can sell. So it's giving us exact numbers. So he has a candle that sells for $2.50 each, and if he has 10 candles, we are going to show how much money we raised for that. So when they're giving you specific values like this, they are going to be discrete graphs. For example, the answer here shows, here's Simon's earnings. It's showing the y-axis is showing the amount earned in money, so they're counting by fives. And then down at the bottom is the number of candles that were sold. So candles sold, zero amount. They sold one candle for $2.50, two candles, and it goes up with the graph. So what this is showing is the amount earned as the y-axis increases by $2.50 for each candle that is sold along the x-axis. Since Simon can only sell whole number of candles, the graph is 11 distinct points, because you need to have, like they said, whole numbers for these candles. So this graph here represents the situation, and this is a discrete graph because it is giving us exact numbers too that we're working with. With continuous graphs, the numbers aren't necessarily exact. They'll say it starts at a certain point and rises or is constant or falls steadily, like the last example shown. The last example here, it says write a possible situation for the given graph. So here we have pizza bought and students. So it looks like the less amount of students we have, the less pizza that's bought. The more students we have, more pizza is bought here. So we need to write a word problem that represents this graph. Remember, this is a discrete graph. So how could we say this? We could put the less students there are, the less pizza was bought. The more students we have, more pizza was bought. So here's an answer. When the number of students reach a certain point, the number of pizza bought increases. And answers may vary with this, but this is one example of how you could write out a word problem based on that discrete graph represented here in this example.